So these notes are actually going to be kind of similar to the other day. Where we're not going to do inequalities. So we're just going to be solving radical equations. And honestly, if we actually had like an uninterrupted week, we could have easily done this entire chapter's worth of everything within this week, because it's all very similar, it's all very tied together. I know the hardest part for you guys is you're probably just going to forget little details of things that we did like 3 days ago when we last met. So, first thing. And again, it doesn't matter what you want to write down, but I wanted to put this up here. When you're doing radical equations, the important thing is that you have the root symbol by itself on one side of the equation. So I guess if you're going to write any kind of notes down, I'd write down the bottom. The two equations at the bottom are the exact same thing, but in terms of solving them and actually finding an answer, the one on the right is a lot easier. Are you writing down notes, Hadley?
Yeah.
Oh. I was trying to look for somebody that wasn't.
Oh, you using the roll?
Yes. Okay. That would be great. Thank you. You pass that down.
Yeah.
So Morgan is afraid that she's going to roll a 2-5 first again? Yep. Okay.
Does it matter which one's the row and which one's not?
Yes. Yes, the pyramid one has to be the row because there's only 4 numbers on that one.
Okay.
And then the other one is the desk.
Okay. You want me to roll?
Sure.
Okay, row 4, seat 4.
Okay, Connor. I don't know if you remember how to do these from before or not. Do you possibly remember how to solve this equation already, the one on the right? Like how you'd find the answer?
That's a great question.
That's fine if you don't. I mean, like, it's going to be the goal of this section. But I know we have learned it a while ago, so that's why I wasn't sure if you'd remember. Sounding like a no. That's fine. Okay, so the way that we would solve this is we want to get rid of the cube root symbol, and so we do the opposite of the cube root, which is cube. Yeah. So if we would have had class yesterday, like a regular week, part of yesterday's was when you were simplifying the fractions, like when we had a cube root symbol and something cubed on the inside of the cube root, they cancel each other out. So my guess is that would have been fresher on your mind. So the way that we would solve this is we cube both sides. Okay? And then the cube root and the cube cancel each other out, and it leaves just the x. So the answer is 8. So the equation on the right, definitely pretty easy to solve. And I don't know if I want to roll somebody for the next one or not. Does anybody know why the one on the left would be really hard to solve? The way it sits right now? So to try to get rid of the cube root symbol, we usually cube. But if I cube the left-hand side, I would have to cube it like that. And why would that be difficult? Like, I know some people in here would make a mistake and just write x cubed minus 8. And that's definitely not right.
It's a -2, maybe, I don't know.
Oh, that's not bad. True, but that's not why it's hard.
It'll turn into like, it'll have 4 terms, right?
Yeah, we would have to cube that, which would mean like foiling it, right?
Or yeah, that's not.
You'd have to foil it multiple times. So this would be not good. The answer on the left-hand side would just turn to garbage. You would have an x, you would have an 8, but then you would have 2 different middle terms that wouldn't be any easier to solve. So on the left, you wouldn't really be able to get an actual answer. And this is the main reason why when you're doing these problems, the important thing to remember is you need a root by itself on one side of the equation.
So could you add the 2 to the other side?
Absolutely. That's exactly what we're going to do, yeah. Yeah, you're just going to make the equation be look correct before you try to solve it. Yep. Okay, so we'll start with these two, which obviously are harder or got more work. And Hadley, whenever you get a chance.
Okay.
Oh, perfect. You're even shaking it up before you put it in.
Alright, row 1, seat 7.
Angelina, do you want, I'm assuming you want a little bit of guidance since we really haven't done any of these yet? Okay. So on this first question, if we're trying to solve a root, so solve a radical, the easiest thing possible for us is if we get the root symbol by itself. Right now there's a times 2 on the root symbol. How would we get rid of the times 2?
Would we do it to the other side divided 2?
Perfect, that's absolutely it. So cancel off the times 2 by dividing 2 on both sides. So then we have root something equals 7. We want to get rid of the root symbol if we can, because then the problem becomes much, much easier. And by far the best way to get rid of the root symbol is to do the opposite of it. This one is a square root, so when there's no number there, that's the same as a 2. The square root is the most common by far, so they just leave the number off. I don't know why. I mean, like, I'm sure it's to save a little bit of writing, but so the opposite of square root is squared. You're definitely going to get used to the fact that you do the opposite of whatever root is there. And then the squared and the square root symbol cancel each other out and just leave whatever was inside. And then at this point, it's just a regular equation. Now it does say check down here. I'm okay with skipping that part for now. There is only one type of equation you're going to have to check. And I don't remember if we're going to get to that today or not. I don't know. Anything on that first one there, like, this is how a lot of them are going to be set up, something similar to that. Is there something on that first one that steps kind of confused you or didn't really make sense? Because I can certainly go over it. All right.
row two, seat three.
That's perfect, because this is the exact question you asked.
Add 15.
Perfect. So if you have a root and an extra number on the same side of the equation, our goal is going to be to get the root by itself. So we're going to add 15 to both sides. So really all that happened is that now this says 5 times the cube root equals 15. Okay, Hadley? A quick text in between you two. Let me guess. It was your mom. Everybody in this class says it's their mom. Oh. Oh, is it 2-5? She's never going to let you roll again. Oh, perfect. So our goal is going to be to get the root symbol by itself. So right now it says times by 5 on it. So we get rid of that times by 5. If there's anything that you need to highlight or whatever in your notes, it's get the root by itself. Yeah. It definitely should. Thank you. I was 100% thinking in my head to start writing that up on top. Good catch. This is absolutely going to be the one thing, if you can remember, will make these problems easier. Okay, now we're going to, oh, actually, you know what, I'll roll somebody. I think we've done enough of this now, people kind of get it.
Row four, seat five.
That is nobody.
Row two, seat nine.
How do I get rid of the cube root symbol? Yep. Cube. To the third power. Is that what you were trying to say?
Yeah.
Okay. Yep. It's all right if you don't know the terminology. But yeah, the cube root and cube are going to cancel each other out. That leaves whatever was inside. It's going to be super hard to remember. Like, I guarantee a lot of you are going to write 9 on accident. Kind of just like when I wrote 5 over here because I saw 5s. And I don't think I need to call on anybody for the end of this because I think you guys are so used to that you'll just know how to solve. Or at least I'm hoping that's the case by now.
That's a tricky one.
Which part?
Bottom part.
Oh, the -3 times divided by 4? Oh, okay.
That's really hard.
That's true. I feel like if you have the first 2 steps down that you should be okay for the end.
Yeah. And you got it.
I don't know. How about either of these two? Like, this is going to be a majority of the problems you're going to deal with today are going to look like this. They definitely get more difficult, but we're trying to kind of work our way through them. So this will be a majority of things today. I think I have a couple for you to try. Sure, why not? We are, at this point of the year, we're not trying to rush through anything. And I want to make sure that, whatever we learn now, you get. So I don't want to hurry through this stuff, and wherever we end up at the end of the year is fine. Today I only wanted to hurry to get started because I wanted to have the recording set up and uploaded and set up before second hour. Or maybe for the people who went to the library first hour as well. They'll need a video recording too. Should I let you guys know ahead of time who's going to be in charge of each problem? Does that help or does that make it worse?
That helps.
Then you could focus on that problem. All right, Hadley, 3 roles.
3.
3. 3 problems, 3 roles.
Okay, row 4, seat 4. Oh,
Let's go.
Already went.
No.
can I?
Give it to me, McLeod. Give it to him.
Okay. Which one do you want?
Pick one for me, McLeod.
Okay, roll the second person. We'll just let you have the third one.
Row 3, seat 8.
I'll take
A? Okay. Well, that works. Okay, one more person. I know I'm really cutting off your work, I suppose.
Row 3, seat 9.
Do you want B or C?
I'll take C.
Okay, Connor, you got B.
Okay.
Are they letting you come back after you're done today? Okay, I'll ask you later. That's okay, I couldn't really hear. Okay, Eli, you said you finished it already? Okay. Can you kind of give me guidance on A?
So you would subtract the 4 first, so you could get the root alone.
Okay, perfect. You want the root alone.
And then you would square the root.
Both sides.
Yeah, you square both sides.
Square both complete sides, yep.
And then you get x minus 1 is equal to 1. And you take the 1 to the other side, and it would be x equals 2.
Nice job, Eli. Good start. Good start. I'm not entirely sure why I have A first. B is probably easier
Yeah.
because there's no steps you have to take first on B. But go ahead.
Oh, okay. So first thing you're gonna do is cube the root and also cube the other side.
Cube both sides of the equation. Yep.
So then you're left with 3x minus 4 equals 8.
Good.
And then you add 4. And then you get 3x plus 12 divided by 3 equals 4.
What?
Divide by 3, x equals 4.
Oh, I thought I heard you say 3x plus 12 equals 4.
No.
I wonder if you were just saying the steps fast enough that I heard them all as one thing. No, that's perfect. And I'm going to guess you guys are okay with me not writing those steps in between just because you've done them so much. I think a lot of you are pretty used to it. And I don't know if it's, wait, who had the third one again? I don't know if it was too early. Or did you get C done yet?
Oh, yes.
Oh, okay.
Yes, I have. Okay, so I started off, I moved to 42. over
Perfect.
to the other side.
Yep, we're trying to get the root by itself.
Positive 42. And then I divided by 6.
Excellent. That gets the root by itself.
And then I.
Oh, I screwed that up. No, you're good. And I know I'm saying this an awful lot. I'm trying to make sure that you just remember that fact. Get the root by itself.
And then I squared this which is, yeah, x plus 10 equals 49. And then x equals 30.
Nice job.
I'm not, I still got the right answer. I just didn't know.
Out of those 3, and I know I was trying to move along so that we have time to work today. Out of those 3, is there something up there that you want me to go over that you didn't get on your own?
Well, I just didn't.
If you were able to do all 3 setups on your own, that's a majority of the problems you're going to have, and that's awesome. On the test, this will be a majority of the solving root problems as well. Yeah.
Alright, for the first one, wouldn't you divide the 4 instead of subtract it?
No, only because that's a plus sign right there. If it was 4 times the root, then you would divide by 4. You're trying to specifically do the opposite of kind of however it's on there. Hadley, do you think you could roll one for me, please? Morgan, were you trying to steal my dice? It kind of looked like it. They're fancy. It is super hard to pick up for me, too.
Row 2, C8.
Adrian, why is this one seemingly more difficult? Why can't we get the root by itself? There is 2. One of them is multiplied by 5. So normally what we would do is divide by 5, but that's actually not helpful in this case because then the other root would not be by itself anymore either. So on this particular problem, we can't get both roots by themselves. I mean, not only adding to the fact that we haven't had one with 2 roots. But it's sort of correct. It's sort of correct because both roots are kind of by themselves. So I could still solve this by squaring both sides. And I picked this example for one main reason. Left-hand side works the same, normal. Root symbol, squared, go away. Right-hand side is sort of. That's kind of a kinda. This 5 that's in here, the squared applies to both the 5 and the root. So this becomes a 25 because you have to square the 5 and square the root. So because you're squaring 2 things, and because they're multiplied, there's a difference between multiply and add. If they were added, we'd have to FOIL this. But because they're multiplied, I can put the squared on both. It's just something you kind of have to watch out for. I'd want to multiply this 25 out now. And then, I mean, from there, the problem's not difficult. You get the x's on one side, numbers on the other. Go ahead. Did I write something too fast or skip something? Diego?
Sorry?
Did I go too fast or skip something?
No.
Oh, you weren't asking about the problem.
Yeah, I was just asking.
Nope, that's fine. I thought you saw something that confused you. Okay, I want to go back and kind of show you something on the first problem we did. Notice A. If I would have decided to square both sides on that step, I could have. I could have squared both sides right away now that we've done one like this. And I could have squared the 2 and I could have squared the root. I could have squared 14, which I think is 196. And then divided by, or, just multiplied out the 4. Hi. Thanks. I wanted to show you this because you're going to get the same answer either way. I think most of you would have an easier time getting the root by itself first because then all of the information is smaller. And having less information to work with is usually easier. So that's why I wanted to make sure and kind of emphasize to get the root by itself if you can. Because I think the one written in yellow is going to be easier for most of you to solve. But I wanted to show you this one just to show you have options. Like, as long as what you do is correct, you're allowed to do it. So, just try B. And then let me double check on the homework. Just try B. I want to say
This is my phone now. Why don't you see it? What?
oh, just B, just B.
For the problems I had too, are the problems gonna have, the same?
Yes, you.
radicals?
Yeah. It is possible to do them with different radicals, but that probably wouldn't be something you'd see until pre-calc. Yeah, no, that's a good question. I can't see you getting a different one. I was about to call on somebody. I almost forgot.
Squares. Oh, yeah.
Row 1, C5.
1, 2, 3, 4, 5. Any thoughts how to start that one? What power? Close. So when we square something like to the power of 2, we would purposely do that to cancel off the square root. Because this one's cube root, we're going to take both sides to the third power. Like we're purposely trying to pick the power to match the root. If the power and the root match, then they cancel each other out. And maybe that's what you meant by it too, I don't know. So cube root, cubed, cancel. Right-hand side isn't terrible, you just have to remember that both things are being cubed. So 2 cubed would be 8, and then you have the root that cancels. Let's see, I'll bring it to the right, bring that to the left. I'm a rebel? I would hope I would be. If I wasn't very good at this by now, I feel like, yeah, I feel like it really wouldn't be my place to teach any of it to you.
That's your day job.
That is my day job, yeah. You should definitely always be good at the job you choose. Okay, I'll show you one more type of problem, and then we're going to stop today. I know. Well, given that this is only the second, oh my gosh, I just realized I'm only going to meet with my second period for one time this week. We didn't have school Monday. We met Tuesday. Wednesday, Thursday was MCA testing. And now my second period I have to MCA test again today. So this is only the second time we've met this week, and that's why I think this stuff, it isn't that difficult. It's just that our days have been so fragmented that you guys, it's really hard for you as a student to keep everything together. Okay, does anybody know why this one is more difficult? It's kind of like the very first one I put up today, why this one would be more difficult without rolling somebody. We're going to square both sides to cancel off the square root. Why is the right-hand side harder when I square it? Because we have to FOIL it. So we have to square the whole side. We can't just square them individually. You have to square the whole thing. So left-hand side obviously is not hard. Right-hand side, you're going to have to FOIL that. And, you know, if you want to do that somewhere else, like scratch work, go for it. So I'm going to do this off on the side in case you guys need refreshing. foiling firsts, outsides, insides, lasts. Okay, so that's what I'm going to put in place of the right-hand side. It's not like it's terrible or, you know, a horrible question. It's just something else to remember. Quadratic, because it's a squared, that means we have to put everything on one side to solve it. So I need to subtract x, and I need to subtract 18. Move everything to the right on this problem. Doesn't matter which side you move them to. Ho ho. Hey, nobody yelled at me for writing -4. There we go. Morgan, I was counting on you to
I was about to.
verify my work here.
I was going to.
I was going to say, because that one didn't factor, which means I messed up something. So this should be -14. That is definitely better. Factoring, multiply to -14, add to -5, -7 plus 2. Hadley, do you think you can roll one more person for me?
Row 3. Seat 9.
Already went.
Seat 2.
Kayla, I underlined extraneous a whole bunch of times in bad underlining.
Okay.
Do you know what that means? Because I know the word is written kind of weird, and so sometimes it's obvious, sometimes it's not.
No.
Okay, it means equations with extra solutions. So an extraneous solution means one that doesn't check. So it's very possible when you guys have to FOIL out a problem, you're going to add an extra answer that doesn't work. That's what extraneous kind of refers to. So Kayla, if you can you, how do I check these? Might be obvious, I don't know.
Plug them in
Yes. Where though?
to the X's.
But I got a lot of X's up there.
In the pink.
In the pink. That's a good description. I was going to ask which line, but pink is much easier to describe. So plug in the 7s into the pink, and I get square root of 25, 5, 7 minus 2, 5. Hey, this one checks. Well, that's good. 7 works. -2 plus 18 is 16. Square root of 16 is 4. Right-hand side, I get -4. Does not check. So just letting you guys know that it is possible some of these answers aren't going to work. And I will probably stop here because I wanted to give you guys some time to work in here to practice them. I know there's going to be all sorts of stuff going on here, so I think today would be a good day for me to be able to try to help you guys out in class if possible. Some of you are doing a great job coming in and getting help and, you know, doing whatever. But at least if nothing, I can help out those who need it in class.